All right, so here, I'll go over this with you guys. So for number 2, it says that you have a vertical spring with a spring constant K of 6,900 newtons per meter, and it's compressed 0.06 meters, and then it has a mass of 0.13 kilograms, and it's placed at the top of a spring and released, launching it into the air. How far above the launching point is the corresponding to the spring's free length as the ball when it reaches a final velocity of 3 meters per second. So let's label this as the final velocity, which is 3 meters per second. We're going to neglect air friction, which makes our lives a little easier. So here's the thing. You can have, and this will be confusing, and I'll try to make it not confusing. What I start with is potential energy from the spring. And that's going to be converted to, because we don't know the height of this. So sometimes this is rigged where you have the final height and all that stuff, but we don't know what the final height is. We don't know the velocity or anything. So this potential energy, and technically if I go back, let me just go back. Really what we have is the initial, which would be the potential of the spring initial, plus the kinetic energy initial, plus the potential energy due to gravity initial. Okay? And so I'm just going to draw a picture here. I have this ball. It's on a spring. I can choose to make this my 0 point if I want. I can choose to make, and remember the spring has a free length that goes like this, and the distance from here to here is my x value, which they say the x value is 0.06, right? Because the spring is compressed 0.06. And my spring has a constant K of 6,900. Oh, that's not it. Totally forgot about my... So I'm not sure. I might make this 0 meters. Okay? But this is the initial stuff. And because I'm neglecting air friction, my final stuff, whatever I have, is going to have to add up. So I've got my spring energy potential final plus my kinetic energy final plus my potential due to gravity final. Okay? So if this ball is sitting still on the spring right before it's released, what is the velocity? Well, my initial velocity is 0. So this whole term goes away to 0. Well, let's do the math. So this is 1/2 kx squared, right? Potential spring energy, plus 1/2 times the mass of the object times the initial velocity squared, and this would be x initial, plus my potential energy, which is the mass times the acceleration due to gravity times the initial height, right? And then over here I have 1/2 kx final squared, and then that's going to be added to 1/2 the mass times the final velocity squared, plus 1/2, no, not 1/2, mgh final. Well, the initial velocity is going to equal 0, so this whole thing is 0. If I make the initial height 0, which helps out, then this whole thing goes to 0. And this is, somebody asked me earlier, will we always be able to factor out the m's? Not in this case, we can't. because there's some k's and x's in there. So now what they really want is they really want our h final, right? They want to know our final height. But when they release this spring, what's my k value going to be? Once that ball gets shot in the air, what's the k value going to be? 0. So this goes away, right? Once they release that ball, that spring's going to come back up here, and it's just going to stop right here. So then my final x, so this is my initial x, my final x will equal 0, because I'm not going to be displaced. I'm not compressing the spring. I'm not stretching the spring. So really what I have when I'm done, this goes to 0, this goes to 0, and this goes to 0. In other words, 1/2 times kx initial squared has to equal 1/2 the mass times the final velocity squared plus the mass times the acceleration due to gravity times the height. And really what they want to know is how far above the launching point. So we really need to find this HF. I don't know. We could plug the numbers in if we want. Okay. Or I could solve for H. So solving for H is an interesting thing that we could do. So the first thing I would need to do is I would need to add this to both sides. So I would say 1/2 times the mass times the final velocity squared to both sides, right? 1/2 times the final velocity times squared. These cancel, and I get 1/2 kx initial squared plus 1/2 mv final squared is equal to mg h final. What do I do next, guys?
Divide by mg.
Yep, I'm going to divide by mg. I'm going to divide this whole thing by mg. Now, what I could do is factor out the 1/2, toss it to the front. And when I do that, my next line, this cancels with this, but my next line becomes kx initial plus, this is squared, mv final squared all over. I'm just going to take the 1/2 and toss it down to the bottom, so I get a 2 on the bottom, mg. And that is equal to my final height from the starting point, from the compressed location on the spring. Whew! Let's plug in the numbers. So I've got 6,900 times x initial, which is 0.06. That needs to be squared plus, wait a second, did I screw up? I did. Guys, you guys got to catch my mistakes. I can't do everything. This is supposed to be subtracting, right? Because this starts off as a positive 2. So then I got to change my little thingy here. Let's see if I can get it just right. Oh, not quite, but that's okay. Minus the 1/2. Okay. So then this down here should be negative. Oh. All right. Sorry about that mistake. So that it shouldn't be plus v mvf. It should be negative. So I just forgot to make that negative. So anyways, let's finish this. So this should be minus the mass of the object, which was 0.13 kilograms, times the final velocity, which was 3 meters per second squared. divided by 2 times the mass of the object, which is 0.13, times the acceleration due to gravity, which is 9.8. And that equals my final height. Okay? So if you plug that in your calculator, it's approximately, did you guys get 9.29? I know you guys do your math ahead of me sometimes. Yeah. Okay. Now, does that help? Okay. Does that make sense? Does anybody have any questions about that problem? It's the same thing, except now we're tracking 3 energies, and you have to kind of think about where you get the values from. Okay? All right, so that's number 2 from your homework.